I thought some of you might need some extra examples on graphing rational functions, so I'll go through 3 or 4 or 5 or how many ever I can fit in a 15-minute video. So let's start off with a basic rational function, y equals, let's do 2 over x minus 3. So if I'm going to graph this function, the first thing I do is I look at the bottom of the function. The bottom of the function tells me what my vertical asymptotes are going to be. X minus 3 cannot be equal to 0, so x cannot be equal to 3. Therefore, the domain of this function in interval notation is negative infinity to 3 union 3 to infinity. The second thing I do is I take a look at the powers. And it's a little bit weird here, but this x is to the first power, but there's no x at the top. And since there's no x at the top, the bottom power is bigger. And when the bottom power is bigger, that tells you that the horizontal asymptote is at 0. So I draw a second dotted line at y equals 0. So step 1, vertical asymptotes. Step 2, horizontal asymptotes. Step 3, test points to the left and right of the vertical asymptote. So at this point in my graph, I'm going to make a table of values for x and y, which I'm making sideways so it'll fit on the screen. And let's try at 0, I get 2 over negative 3. Let's try at 2, I get 2 over negative 1. And at 4, I get 2 over 1. I plot each of those points. Here's 0 and negative 2/3. Here's 2 and negative 2. So this graph is trapped here. And my next point is at 4 and 2. This section of the graph is trapped in here. I already have my domain, but my range is given by, and remember range is going up and down, so if you look here it goes down forever, if you look here it goes up forever, but there's this asymptote that blocks the range, and so my range is negative infinity to 0 union 0 to infinity. Here's another example of a rational function. Step 1 is you're going to look at the bottom of the graph, and in this case, when I'm looking right here at the bottom and asking myself if x squared plus 2 equals 0, what are the sort of gaps in my domain? And you can't have something be squared and equal to a negative 2, so there's nothing that makes the bottom 0. So this graph has no vertical asymptotes. So the second thing I look at is the powers on the top and bottom. In this case, the power on the bottom is 2, but there's no power of x on the top. And so since the bottom power is bigger, that makes my horizontal asymptote at y equals 0. So I draw in my only asymptote, y equals 0. Since the only asymptote is y equals 0, there's no restrictions in the domain. So the domain for this function is going to be all real numbers, which in interval notation we write as negative infinity to infinity. So then I work on the actual table of values for the graph, and if I pick the point 0, I get 4 divided by 2 or 2. If I pick the point positive or negative 2, I get 4 divided by 6. If I pick the points positive or negative 4, I get 4 divided by 18. If I pick the points positive or negative 1, go back a little ways, I get plus or minus 4/3. If I plot these points, here's 0, 2. Here is plus or minus 2 and 2/3. Here's plus or minus 1 and 1/3. Here's plus or minus 4 and 2/9. So this graph appears to be sort of a lump in the middle. It goes on forever in both directions as it approaches the asymptote, so the domain is all real numbers. The range for this graph, remember range goes from lowest to highest. Lowest to highest. So it doesn't quite touch 0, so 0 is not in the range, but it does go up to and include the point 2, so 2 is included in the range. When you're looking at range, you're looking at the lowest point, almost 0, to the highest point. I'm going to keep doing a few more examples of rational functions. Only take a look at these examples if you need extra help, because it just goes through the process each time. Step 1 is to look at the bottom, because the bottom is going to tell you what makes the vertical asymptotes. So in this case, I cannot have x minus 4 equal to 0 because I can't have a 0 on the bottom of the equation. That factors as x minus 2 times x plus 2. And so therefore, x cannot be equal to 2 or negative 2. This makes this graph have a vertical asymptote at positive 2 and also have a vertical asymptote at negative 2. So the second place I look is I look at the powers. In this case, I have an x squared on top and I have an x squared on the bottom. Since they have the same power, then I go for a fraction of the coefficients. The first coefficient is 4, the bottom coefficient is 1, and so the horizontal asymptote is at y is equal to 4. So now in making this graph, I need to test points to the left and right of each vertical asymptote. So I'm going to try some points. I'm going to probably try negative 3, positive 3, negative 1, 0, and 1. At negative 3, I've got 36 divided by 5. At positive 3, I have 36 divided by 5. At negative 1, I have 4 divided by negative 3. At 0, I have 0. And at 1, I have 4 divided by negative 3. If I plot each of those points, at negative 3, the graph is up fairly high. 5 goes into 36, 7 and something times, so 1, 2, 3, 4, 5, 6. It's off the edge of the graph, but it is up here in this section. And same with positive 3. It's off the edge of the graph, but it is up here. So then I look at the point 0, 0, 1 and negative 4/3. Negative 1 and negative 4/3, and it appears this graph goes down in both directions. So actually this is an interesting graph for domain and range. Remember, domain you're looking left to right, so if I'm looking this way, I go from negative infinity until I get to negative 2, and then I have a break, and it goes from negative 2 to positive 2. Then I have another point of discontinuity, and then it goes from positive 2 to infinity. But if I look at the range for this graph, it appears to not have any points. Let me change colors on you for a second. See this area right here? there's no y values in this area. They're all above or below. And so the range is going to go from negative infinity up to 0. It's going to include 0. And then it's going to start back up just above 4 and go to infinity. Interesting range. And, you know, rational functions are always kind of weird and interesting, and you never know quite how they're going to turn out until you graph them. For the last graph, let's look at something a little bit different and interesting. How about y equals x squared minus 9 over x minus 3? So I start off as usual thinking, oh, this must have an asymptote, because an asymptote is whatever my teacher told me makes the bottom 0. And so I'm thinking that since I have x minus 3 can't be 0, that x can't be equal to 3. And I draw in an asymptote. Well, it turns out this actually doesn't have an asymptote at all, because if you were to factor the top, y equals x squared minus 9 becomes x minus 3x plus 3, and the x minus 3 on the bottom is going to cancel the x minus 3 on top. Boom, boom. Y equals x plus 3. All I really have is a line. And I kind of know that I'm heading there from the very beginning, because the top power is 2 and the bottom power is 1. And if the top power is bigger, there's no horizontal asymptote. If there's no horizontal asymptote, I really need to start off with long division before I even get going, making sure, do I have a line or do I have a slant asymptote? In this case, I have the line y equals x plus 3. So this line goes here, but I still have the problem in the original function that I can't have 3 in the domain, because if I put 3 into the original equation right here, I'd end up with 3 minus 3, which is 0, and I can't have 0 on the bottom. And so that, instead of making an asymptote, it's going to make a point of discontinuity, or it's actually called a hole. And so for this graph, the domain is going to be negative infinity to 3, union 3 to infinity. And the range is going to be negative infinity to 6 and union 6 to infinity. Okay, last rational function of the day. Let's look at 2x over x plus 2. We're going to first all look at the bottom of the function. It's got a vertical asymptote at negative 2. Then we're going to look at the powers. These are both x to the first power. So I go for the fraction of the coefficient. So the horizontal asymptote is at positive 2. And for my math joke of the day, holy graphing, Batman, look at the asymptote on that mother function. Although you still have to actually finish up the problem with the table of values. For x and y, if I test a point at negative 3, I get negative 6 over negative 1. If I test a point at 0, I get 0. And so this graph is going to be trapped down in this lower right-hand quadrant. And it's going to be trapped up here at the point negative 3, 6. Up here. And if I were to give the domain, which remember, despite all this miserable graphing, the whole point of this entire assignment is that you can give domain. It goes from negative infinity to negative 2, union 2 to infinity. Hope you liked the extra examples and stuck around for the joke.